So now that I've walked through the overall intent and applicability and structure and functionality and consequences and known uses of the command processor pattern, let's take a deeper dive in terms of how it's actually implemented. And we're going to talk about how this pattern is implemented and applied in the context of both Android and Java. And as I had mentioned before, there's great Android use cases, and there's also great Java use cases. So naturally, Android uses a lot of Java, but you can also see this pattern being applied in the context of Java and just good old vanilla Java on the Java platform without any reference to Android. So let's start off first by talking about how you implement this pattern. The first thing you need to do is you need to define an interface to execute commands. And there's lots of different ways of doing this. Of course, my recommendation would be, if at all possible, to use some kind of functional interface. And a classic example of a functional interface that you undoubtedly all know and love if you're a Java programmer, especially a concurrent Java programmer, is the Runnable Interface, which has a run hook method. So we're all familiar with that, I'm sure. You can see this link at the bottom of the slide for more information about Runnable. So what this does, what this interface needs to do, is it needs to define at least one method that can execute the command if the processing can be localized. And that's not always easy, but you can usually find a way to adapt or proxy things to get that API. So the next thing you need to do is you need to be able to add state and methods that concrete commands will require in order to perform the execution of the command request. So let's take a look at some examples here. So here's an example where we're going to use an anonymous inner class to go ahead and implement a command interface. Now, there's, again, lots of different ways to do this. If we were programming in modern Java, we would probably be tempted to use something like Lambda expression. But the nice thing here is that this code will work on pretty much any version of Android, even versions that go back before they supported modern Java. So you can see we make ourselves an anonymous runnable with a run hook method. So that's how we're going to implement the command interface. So then what we're going to do is we're going to define and implement the creator. And this is typically done by using some kind of creation pattern like abstract factory or factory method and so on. In this particular case, we're not going to that much trouble to make a separate factory method called, make command. We're just going to make a new instance of our runnable command that uses anonymous inner classes. Then you also have to figure out a mechanism to pass the command to the executor of the command. So thinking back to what we're doing here, we're going to have a background thread that's going to be downloading this image. And then we're going to have a way to pass that runnable command that we make, which will contain the results of downloading the image, to the user interface thread. And this is done with a very special method that's defined in Android called runOnUIThread. And this is defined in the activity class in Android, which has a lot of interesting hook methods. But in this particular case, there's a way of being able to pass a command from a background thread to the user interface thread. And that's exactly what we're going to do here. We then have to go ahead and define the execution context, which is the runtime environment to process the command object. As you can see here, in this case, that's going to keep track of the bitmap that we will have gotten once we've downloaded the overall image from the remote web server where it resides. And then we're going to have the context in which this is going to run, which is going to be able to interact with the user interface through something called an image view. And down here, you can see this is sort of that closure-like mechanism where we're able to access the state of the context in order to be able to have the user interface thread set the bitmap to be displayed based on the bitmap that was downloaded in the background thread. Next, we need to be able to implement the executor. And the executor, of course, is the piece of code that's going to receive the command from the creator. And at this point, now we're kind of turning our attention to the inner workings of Android. And we'll talk more about this as we get further along into other patterns, specifically patterns like active object. But the Android Hammer framework, which is what we're focusing on at this point, has several main capabilities, one of which is the handler. And the handler is essentially an interface or a proxy that can be used to pass messages from background threads to foreground threads, or from one thread to another. And so in this particular case, the handler has a method called post, and you give it a runnable, and it goes ahead and it sends that runnable from one thread to another. And you can see the source code for handler if you go here and take a look at the Android source code, which of course is all available in open source form. So the way this works is that the run on UI thread that we were talking about a moment ago, which is part of the activity class, uses the post method on a handler to pass a command from the background thread, from the calling thread, to the user interface thread where it's actually going to be executed in the user interface context. Internally, the way things work is that runnables, when you basically do a runnable, that will be encapsulated within something else called a message. So that's where the HAMMER acronym comes from. So we have handlers, we have messages, and we have runnables. And just as an implementation artifact, the runnables are encapsulated in messages. So you can see here that what happens is when you want to, when the Android framework is going to be working with runnables, the Android HAMMER framework, it takes a runnable and it makes something called a post message, where it makes a new message by calling the obtain factory method on the message class, and then it encapsulates the runnable in the callback field in that message and returns that field. So you can kind of see that logic being done here. The send message delayed message, as you can see, calls get post runnable to convert the runnable into a message, and then it goes ahead and posts that message. And it uses a helper method called send message at time. Now, this particular use case is not based on time. It's not going to say defer this message to run 20 seconds from now. It just says go ahead and put this message in the queue with no particular timeout. But it's also possible to in-queue messages that will run at some point in the future, although we're not using that particular feature here. And that's why the send message at time method, which is what we're using here to in-queue the command for later processing, also supports the ability to handle timeouts in the future. So in this particular case, we go ahead and make the target of the message this, which is the handler that we're referring to. And then we go ahead and we in-queue that message in the queue. And then the in-queue method that's called is going to go ahead and determine when and where to in-queue the message in a doubly linked list. That's what's being used under the hood in the Android framework in order to keep track of things that are passed from one thread to another. And you can take a look at all the source code if you really want to learn the inner workings of how the Android message queue class works. It's really pretty cool. And then if we need to, we're going to go ahead and pass something that will say, wake up the receiver so it can receive this message and pull it out of the queue. And this is all handled by something else we've talked about in an earlier video called a looper. So if you recall, you can have looper threads in Android, and the UI thread, the user interface thread, is a looper thread. It's a special looper thread. And that basically is the reader side of this protocol. So the in-queue message side is kind of the writer side or the sender side. It's plopping in the message into the queue, and then that will wake up the reader side or the receiver side running in the looper. And here's kind of what the looper looks like. You can see this code. This code is what's used in the user interface thread to dequeue the command and then execute it in the right context. So you can look at the looper code if you want to see the source, but basically what it's doing is just sitting in a loop, blocked, waiting for the next message to come in. And so queue.next is a call that's just going to block until there's something to do. That's really the one and only place that the user interface thread blocks, and that's waiting for the next event to show up or the next message to show up. And what it does is once it's got that particular message off the queue, it says, message, go ahead and dispatch yourself on the target, which is the handler we just looked at. And what that does is that ends up executing the command in the appropriate context, which in this case is the user interface thread. And so you can see here that dispatch message takes a message. It checks to see whether or not the callback is null. If it's got a null callback, that means it's not a runnable. It's not encapsulating a runnable. If it has a null callback, that means it's a message. If it's a non-null callback, that means it's encapsulating a runnable. And in that particular case, it'll handle the callback on the message. And as you can see, what the handle callback method does is it just says message.callback.run. So at long last, we're able to execute that operation, in this case, to download the image, to display the image. That's going to be run in the context of the user interface thread through this somewhat torturous sequence of method calls. The good news, of course, is all of this code is hidden from you as a user of Android and its Hammer framework. I was just showing you how you could implement this framework if you were so inclined. So this particular run callback will, in fact, execute in the context of the user interface thread. So this particular pattern is applied in a lot of different places. Of course, it's applied in Java's ThreadPoolExecutor, which implements the command processor pattern. Now, this particular mechanism is not what we're actually looking at here when we looked earlier at the way in which the run on UI thread mechanism worked in Android. But just be aware that Android contains the Java concurrency mechanisms that are provided in Java util concurrent. And this includes things like ThreadPoolExecutor and Executor completion service and so on and so forth, all of which themselves implement variants of the command processor pattern too. So there's multiple examples of the command processor pattern lurking in the Android source code. Some comes from the Android parts, some comes from the Java parts. And in fact, if we were so inclined, and you can go back and watch the videos that we talked about the Executor framework, you could see that there's lots of cool mechanisms that are available in the Java Executor framework for doing command processor implementations. So runnables and callables can be used to execute various types of commands. We'll also talk later about how other patterns are lurking inside of the Java Executor framework, things like the active object pattern, things like the proactor pattern, and so on and so forth. So the way this works, of course, if you're just focusing exclusively on Java's ThreadPoolExecutor and how it implements the command processor pattern, a client will pass, it'll basically pass a runnable task to the execute method on the ThreadPoolExecutor. And what the Executor framework calls a task is what we would call a command if we're thinking about the pattern terminology. And internally, these tasks or commands are executed by a worker thread, because there's typically a pool of these things running inside the ThreadPoolExecutor. And there's a blocking queue that's used to pass tasks or commands from the client, from the caller that invokes execute, to the worker thread that will actually run that command, that task in a background context. There's a bunch of other cool things, which we're not going to go into detail here because they're covered in other videos on the Executor framework and specifically the ThreadPoolExecutor. But there's different kinds of queues that can be used to pass messages from the client to the thread pool, including direct handoffs, which is what's used by the cached thread pool model, unbounded queues, which are what are used by default by the fixed thread pool example. And then there's other things like bounded queues, which don't really come supported out of the box, but you could tweak and tune as you saw fit by programming directly to the Java ThreadPoolExecutor, if that's what you'd like to do. So to summarize this discussion of the command processor implementation in Android and Java, we focus primarily here on walking through the Android Hammer framework implementation of the command processor pattern and showing how you can use it to pass commands from a background thread to the user interface thread. There are other patterns involved, which we'll talk about shortly. There's things like thread-specific storage and result callback and guarded suspension and all these kinds of good things, but that's a little outside the scope of what we're talking about here. So that's the end of our discussion of the command processor pattern. Hopefully this is helpful for you, and hopefully it'll also give you a better appreciation of how this pattern is realized in both Android and in Java in order to be able to decouple clients that want to create requests from worker threads that will process those requests in a different context.